Good evening, sir.
Good evening, Saiti. Nanika, good evening. Okay, almost everyone has joined. So today we shall quickly start with the chapter light, which we had done in the last class. We had done about the laws of reflection. We had done about regular and irregular reflection. All right. I was talking to you about real and virtual images, right? So that was the last discussion, real and virtual images. So can anyone recall what are real images? Yeah. Pranav, can you recall what are virtual images? Gagana, what are real and virtual images?
Sir, virtual images are the images created by plane mirrors. So this is Nanika, by the way. Created by plane mirrors, which cannot be projected onto another screen. Whereas real images are the images made by convex and concave lenses, which can be projected onto another screen. Example, like a flame of a fire, like a candle, can be reflected or create a real image onto a screen when being used by concave or convex mirror, whereas the same flame cannot be reflected onto a screen by a plane mirror.
All right. So I have.
And actually, real images, the light rays actually meet to form a real image, and light rays do not meet to form a virtual image.
Okay. And can anyone tell what is the difference between an image and a shadow?
Sir, a shadow is when light rays cannot go through an opaque object which creates an outline and which causes it to create a figure or a silhouette of an object. Where, sir, you said image, right? Sir, what is an
Yeah.
image?
Yeah. What is an image? That I want the difference between image and a shadow.
Sir, a shadow is like formed when no light can pass through. That's why it is black. And an image is basically the reflection of what the object we show. It is when the light rays reflect off of an object.
All right. See, almost clear. I think you have the definition. Just let me clarify to everyone the difference between a shadow and an image. A shadow is not an image. Okay. So what is a shadow? Let's see. So shadow,
Sir,
it
image
is,
can even say it is an illusion.
yeah, image is an illusion. So
Got
shadow, that we call as an optical illusion. So what is a shadow? It is a black patch of light. It is a black patch obtained when the path of light is obstructed, when the path of light is obstructed by an opaque object. When the path of light is obstructed by an opaque object, then we call it as a shadow, right? It does not contain the minor details of the object, whereas an image contains the details of the object. So I think how many of you have seen a concave mirror? Is there anyone who has seen a concave mirror?
Sir, I saw once a
Sir,
concave mirror. In my
the
school, they showed
concave
an
mirror,
experiment.
spoon, sir. The spoon could
Okay,
be
okay, okay,
concave
okay,
and convex
okay.
mirror.
That's good. If you have seen that in a school, that's good. Otherwise, see, I can show you if you go to your kitchen and just take a new spoon. Okay, so take a new spoon over there. The inner chord portion of the spoon behaves as a concave mirror. Okay, if you observe your image in that spoon, you will observe it to be inverted image. Okay. So just see how you will see your image in a spoon. You can just go see your kitchen over there. You will have, and you can see this one. uh, Inner surface of spoon as concave mirror. So this is a concave mirror, and you observe your inverted image. Right? So see, just like this. So in this one, you can see two surfaces have been shown here. See, okay, this new one. Let me show this one. All right, here you can see this one shows an inverted image, whereas the outer portion it shows the outer image. Okay, so here you see an inverted image in the inner part of the spoon. You observe an inverted image. All right, so that is uh, concave mirror. Okay. Now let's see. I think everyone is clear about the real and virtual images. Charantis, what is a real image and a virtual image?
Sir, a real image is an image means which can be means obtained on a screen, sir. Virtual
Okay.
means which cannot be appear on which cannot appear on a screen, sir.
Okay. So, what about the images in a theater?
Sir, it is real image.
Yeah. So it is a real image which can be obtained on a screen, and they are formed by actual meeting of the light rays. They are called real images. Okay. Then virtual images are the images. Virtual image, it is the image that cannot be obtained on a screen.
Sir, like we can imagine real image, but how virtual image will be?
Yeah, how can virtual image be?
How can how can the virtual image be like?
Okay, how would it look like? You want to know. Okay. So if you observe yourself in a plane mirror, okay, every day you observe your face in the plane mirror, the image that you see is a virtual image, it's not a real image. As you can't get it on a screen. Okay, just let me show. I will able to show you a real image. So I have a concave mirror. Let me show you a real image. Okay. So the mirror that I have, it is spoiled now. It's not good. So it won't form any images. All right. So Pranav, the images, even in your plane mirror, they are all real images. I will just show you with the ray diagram how can we observe real and virtual images. You see, now we are looking at image formation by a plane mirror. This is a very important concept. Image formation by a plane mirror. See, here I'm taking a plane mirror. Let's take this one to be a plane mirror. And let's take one of its sides to be a polished surface. So I'm taking this side to be the polished side, so that the front of the mirror will be a shiny surface. So which type will be the front surface, you'll be able to identify that this is the side where you have, or this is the thing which is front, it's kept in the front of the mirror. So this side is the back of mirror. Now when and where we will be able to see the image. So see, for forming the image, we consider here two light rays. So we have a light ray which is coming towards the plane mirror. Okay. So can anyone tell what will be the angle of incidence if it is falling normally on it? What will be the angle of incidence for it?
0.
0. Its angle of incidence would be 0 and it will get reflected back along the same path. Alright. So it will get reflected back also like this.
Sir,
So
but it's perpendicular, right, sir? So I think it should be 90, right, sir?
no, the ray is perpendicular to mirror, but the angle of incidence is 0 degree. As the angle of incidence is defined between the normal and the incident ray.
Okay, sir.
So here angle of reflection is also 0 degree.
This is reflecting back straight.
Yeah.
Like why it is reflecting back straight?
Just repeat what you're saying.
Why it is reflecting back straight, sir? Like how it can
reflect, because when it strikes a mirror, okay, so the mirror will reflect it back. Reflection occurs from shiny polished surfaces. When light falls on shiny polished surface, it bounces back in the same direction, right? So this phenomena being called as reflection of light. So this is a natural phenomena which occurs when a ray of light falls on a mirror. Okay, Prana, any doubt? So reflection occurs as an interaction between a particle and photons. When photons fall on any particle, there are different types of interactions. This is one of the interaction by which we talk of reflection taking place. Got it? Okay. Now let's say we take another ray of light. So here I take another ray of light which is falling on the mirror at some other place. So let's say it falls over here. Now from this place also, the ray of light gets reflected. Just taking the help of the normal, we draw the angle of incidence here. So this is our angle of incidence, and the reflected ray should make the same angle as with the incident ray. So at the same angle, your reflected ray also gets reflected. So everyone has understood here how the two rays have been drawn. This is your object. Let me mark this as A. So A is the object, and from the object A, you have two light rays coming out. One of the light ray, it passes straight to the mirror. The other light ray, it also passes to the mirror, but it is at a certain angle. So here you have the angle of incidence, and the same will be the angle of reflection, and hence it passes back. Now, as I can see, the two reflected rays, they never meet each other. Yes. Do they ever meet each other? Do the reflected rays ever meet each other? No. The two reflected rays never meet each other. But if we try to extend them in the backward direction, you see, by extending these light rays in the backward direction, here I extend this light ray in the backward direction. Extend this in the backward direction. I extend this reflected ray also in the backward direction. So the two rays of light, they are actually not crossing the mirror. Okay, the rays of light, they are not crossing the mirror, but they appear to meet at a certain point. It seems that the two light rays, they are coming from some common point, right? So from this side we are observing from here, we are observing the image from this side. To our eye, we are observing from here. So when we observe from here, we observe the two light rays. They seem to appear to us to be coming from a common point here. And hence, the image of this point A would appear to be at this point inside the mirror. So you will observe this object to be located inside the mirror. Okay? The distance of the object from the mirror will be the same as the distance of the image from the object. So here you will see the image A prime. The object distance, let's say this be P. So I will get that the object distance PA will be the same as the image distance PA dash. This can be shown by congruency also. I think you have studied about congruency. So with the help of congruency, it can be shown here. This diagram, it shows us the image formation by a plane mirror.
Congruency means the similarity between two triangles.
Yeah. So by that way, you can say that these two triangles, they are equal, and hence the distance AP and A dash P are the same. Yeah, what happened? What happened? Repeat. Okay, now see what are the characteristics which we see when the image formation takes place in a plane mirror. So we see here characteristics of the image. So one by one, we will look up at different characteristics. Characteristics of image formed by a plane mirror. Okay. So what are the characteristics of the images which are formed by this plane mirror? We observe the image to be laterally inverted. The first thing we observe is lateral inversion. Okay. So can anyone tell what is lateral inversion?
It will be upside down.
No, it's not upside down.
It's laterally inverted.
Yeah, it's laterally inverted means it is from the left side appears right and the right side appears to be left. So such an image we call as a lateral inversion. So lateral inversion means the left appears to be right.
Sir, for example, our left hand appears as right hand in the image like that, right, sir?
Okay, yeah. So that's the thing, but you need to understand how it works. Okay? So the left appears to be right and right appears left. This we call as the lateral inversion. So see how it happens, the lateral inversion. You take a mirror and in that mirror, let's say I have taken a plane mirror over here. And if I observe the letter A inside it, I write here A and I observe this, so it will appear to me as A only. If I write here B, so how will I observe? Should I observe it like this? Yes. So do you see that the left and right have changed? Yes or no? If you observe the letter C will appear like this. It's like this. So you will observe lateral inversion. That means the left appears right and the right appears to be left. Got it? So if you stand in front of the mirror and you raise your right hand, okay, your image also raises the hand, but the image raises the height that the hand that the image raises, that is the left hand of the image. Are you getting? Yeah, Charantej?
Yes, sir, I got it.
Okay. So lateral inversion, the left appears to be right and the right appears to be left. This we call as lateral inversion. Then we observe that image formed is a virtual image. So in all these cases, we observe image to be formed as virtual image. So here, the second characteristic of this image is image is virtual and same size as the object. So the size of the image is the same as the object. It is not changed. It remains the same.
Sir,
Yes.
instead of virtual, if it's real, the size will be different or it remains the same.
Sometimes the virtual images can be also of different size. For example, in the case of spoon, if you observe on the outer side, okay, so the image is smaller as compared with the object.
Okay, sir.
All right. So image is virtual and same size of as the object. Then the third thing is that the distance of image is same. The distance of image from the mirror is same as that of object from the mirror. So the distance of image from the mirror is the same as the distance of image from the object from the mirror. So object, you can say that the object distances and the image distances are the same. Okay. So is there any characteristics which you think should be included here? Charantej?
Sir, the image is erect.
Yeah, image is erect. Yeah, very good. So this is the fourth point which we can include, that here image is erect. It's not vertically inverted, it's erect. All right. So these are the few characteristics of the images formed by a plane mirror. Now let's try to do one question. Okay. So from now, we start with one question here. Okay. So see, a child runs towards a plane mirror with a speed of 2 meters per second. Okay. So how much speed will he observe of his image? So how much will, how
Sir,
much?
it's 2 meters per second.
2 meters per second?
Yes, sir.
Sir, I've
All
sent
right.
the answer in the chat
Yes,
box.
sir, it's correct, sir.
Sir, I've sent the answer in the chat box.
Okay. I'm just checking the chat box. Okay, so everyone has given the answer. All right. So let's see. The answer is here. I give you the answer. Try to understand what is happening. The question is very good question. Okay, it's an Olympiad question. So see here, you have the mirror. Let this be the polished side. So you consider the object to be located at, let's say, some distance here. So image is also located at the same distance. Let initially the distance between them be uh, 6 meters, whatever. Let the initial distance between the object and the mirror be 6 meters. I'm just considering as an example. You can take anything as an example. So here I have initially I consider the distance here to be 6 meter, and let this distance also be 6 meter. So as the object distance is same as the image distance, so it would remain the same. As I can see, the child runs towards the mirror with a speed of 2 meter per second. So after 1 second, the child will have covered a distance of 2 meter. All right, and it will be like this. The child has covered a distance of 2 meter. The image has also moved through a distance of 2 meter now. Got
Sir,
it?
the answer 4 meter per second.
Yeah, the answer is 4 meter per second.
Okay.
So here the image has also moved through a distance of 2 meter. Now you can check here that now the distance between the object and the image, which was earlier 12 meter, now the distance between the object and the image is reduced to 4 plus 4, that's only 8 meter. This is 4 meter here, 4 meter here. So now the distance between them has changed to 8 meter. Okay. So how much distance has been traveled relative between them? That's 4 meter, and hence the speed that he will observe is 4 meter per second. Got this?
Yes, sir. Yes, sir.
Okay. Now, with reference to the plane mirror, you have one more concept. That is the number of images formed by plane mirrors. Now, this is a very good question. You also get questions related with this topic. The number of images formed by plane mirrors. So what I'm talking of, I'm not talking of one mirror. See, I'm talking of mirrors. So if you have a number of mirrors placed at certain angle with each other. So let's say, let us try to place these two mirrors. So this is one mirror, another mirror placed at 90 degree to each other. You can have a mirror and another mirror placed at an angle of 45 degree to each other. Okay. So you can have a mirror, another mirror placed at an angle of 40 degree to each other. So let us try to find out what will be the number of images that you can see. So here you have these two mirrors, and let's say the angle between them is x. So here it's 90 degree. Here the angle is some 45 degree which I have chosen. Here the angle is 40 degree. Okay. So the number of images is obtained. Number of images is given by the formula 360 divided by x, where x is the angle. So this is 360 divided by x if it's odd. Sorry. Yeah, if it's odd, and 360 divided by x minus 1 if it's even. What do I mean by this? You divide 360 by the angle, whatever number you get. If that number is an even number, you have to subtract 1 from it. And if that number is an odd number, so that will be the number of images of. For example, in the first case, you have 360 divided by 45. So let's find out the number of images in case 1. You get 360 divided by 45.
Sir,
So that is how much?
sir, first angle is 90 or 45?
Oh, sorry, it's 90. My bad. It's 90 degree. It's not 45. So the first angle is 90 degree. Alright. So if you divide this by 90 degree, what should be the number of images? You get your answer as 4.
3 images, sir. 3 images.
Yeah, 3 images. So since this is an even number, you will subtract 1 from it, and hence the number of images here will be equal to 3. 4 minus 1. It's 4 minus 1, that's 3. What will be the number of images obtained here? So it will be 90 divided by 45, and 90 divided by 45 is 8, and 8 minus 1 is 7. Hello? 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 Tuesday, no, this is physics class. Tuesday not at PM. Tuesday 7 p.m. No, not 8 p.m. 7 p.m. You just send the reminder 7 p.m. Yeah, just for today's Wednesday. Okay, just I'll check my I'm in the class. I need some time to. Okay. Okay, all right. So you got in the second one, you have 360 divided by 45, that's 8, and 8 minus 1 is 7. So the number of images here will be 8 minus 1, which is 7. What will be the number of images here? What will be the number of images?
9 images.
Yeah,
Sir,
8.
9 images.
Yeah, it's 9. It's 360 divided by 40. So you get 9. So the number of images would be 9. 9 is an odd number. So n is the 9. Got it? So if it's odd, you keep it as it is. So every time the number of images that will be obtained will always be an odd number. It won't be an even number. Got everyone?
Yes, sir.
Sir, so if by 360 degrees by 90, we get 4 means we need to do minus 1.
Yeah,
Then
that's
3
an
images will be formed.
yeah.
Sir, what if we get a two-digit number?
Even then, even if you get a 2-digit number, then also the same rule applies. Okay. Then also it's the same rule. Like if you go to a barber shop, okay, you observe two mirrors placed almost parallel to each other. They seem to be parallel to you, but one of the mirror is slightly tilted to it. Okay. So you observe one mirror like this. In a barber shop, you observe one of the mirrors like this, and the other mirror has to be here. So the both the mirror, they appear to be a little bit inclined to this. You can observe the mirror which is kept in at your back. That is a little bit inclined like this. Okay, somewhere like this. You can see. So the angle formed between them is decreased. The angle between the mirrors is decreased so that the number of images will be high. Got it? You
Yes,
see
sir.
a lot. You see if you bend it down. So whenever in this case, even if you bend it down or whatever way you see, the maximum number of images that can be obtained will be given by the formula. Got it, everyone? So today we understood two important concepts. We understood the image formations by the plane mirror, and we understood the number of images obtained by the plane mirror. That is, we also call it as multiple reflections. Okay, so this question is from multiple reflections. Right? Okay. Bye everyone. We'll see you again in next class. Yeah?
I have a doubt, sir.
Yeah, please. Please.
Like, if we see 180 degrees and 360 degrees, they will look like a similar no, sir.
Which one?
180 degrees and 360 degrees, no, sir. They will look similar, no, sir.
180 degrees.
And 360 degrees, sir.
Okay. So how many images will you see?
Yes, sir. Like 180 degrees is a straight line and 360 degrees also a kind of straight line, no, sir. Like you will see them similar. So, how can be the number of
See.
images different, sir?
Okay. See. If it's 180 degrees, so you have the mirrors like this. The two mirrors placed like this. All right. So how many images? This is 180 degree. How many images you obtain? You obtain here two images. Hello. You obtain here two images. All right. One in this mirror, one in this mirror. So there are two images. And that's two or one. Ashwani.
Two images.
Hello. हाँ बोलिए हाँ बोलो बोलो जल्दी बोलो okay so sorry I'll just we'll see you in the next class all right okay bye
No.